Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
Welcome to this episode of the Software People Stories. I have a very special guest today, the Chief Architect of Aadhaar, Dr. Pramod Varma. In this conversation, I try to understand the mind of an architect, particularly when designing human-scale systems. He also shares tips on how to become a better architect by focusing on some key basics. Listen on. Welcome to the Software People Stories, Pramod. I've been waiting to talk to you and then understand what is Pramod Varma as a person and how your own evolution has been in terms of creating these scalable systems. And in one of the references, I noticed that you're called as the scalesman. So normally we start with a self-introduction as to how you got into IT and also your background, whatever else you want to share, and we can take the conversation further from there.
Okay. Yeah, pleasure to be here and absolutely happy to share the journey and happy to share the learning. I'm still a hands-on person, so I can totally understand what life of a software engineer turning into technology tech leads and then later architects and then probably even technology entrepreneurs and businessmen. You morph yourself into all these things, right? Yeah, happy to share. So let me start. I was born in a small town in Kerala, grew up there, didn't even hear about IIT and all that thing when I came out. And all in Malayalam medium as well. It's not even English medium. So I didn't even study English medium. So it was a little bit hard in the early days to be able to understand what you want to do. You realize that you have a capability, you have aspiration, but you are in a context where everyone around you is just doing small things around you, and small village or town, that's what happens, and there's nothing much going on. So sometimes it gets tricky. And then so I broke away, went into my master's and did my applied mathematics, and then I wrote GATE and did MTech computer science. But I think my programming started, my first experience of programming actually, frankly, was in high school when one of my friend's brother brought a programmable, the early days of gaming console. Where you punch in and create a little bit of your own. I didn't realize it was programming. I didn't realize it was more of a fun thing we were doing, trying to create your own games or trying to create your own sort of configurations in that sense. It was not complex. It was pretty straightforward. Then subsequently again when I started my math masters, applied math, because it was applied math, I started with Fortran. Fortran it's a scientific language that time. So
probably reveals our age, but
yeah. I know, dinosaurs. but I think that gave very interesting perspective about getting the machines to do something interesting and complex, computationally complex, especially with Fortran, in a jiffy, right? It's so easy to do, and then you get a thrill out of it that you get to do. That is when you realize that you like it, you want to be able to continue doing that. So I went on to MTech computer science because of that shift. I also did pattern recognition, Fourier transforms, some of that during MSc itself, because of applied mathematics, right? So it was including discrete maths and regular expressions and context-free languages, context-free grammar, context-sensitive grammars, all that good stuff about Turing. So I already got enough exposure by my math masters itself that computer science is something which I want to take it up, and then shifted there. But after that, it was, of course, because I was doing computer science, I knew you had to do formal course in operating systems and multi-threading. And by that, I was working on PDP level, DAX. That, again, new guys would wonder, never heard it. Yeah, they were the machines of that time.
Right.
They were very, after IBM and digital DEC machines. Then obviously started with 1K, 32K, 64K kind of memory PCs. By the time PC had arrived and Windows, early DOS machines were already in play. very much. Windows 3.1 had already come out late 80s, mid 80s, I think, right? That's when they released. India already started seeing this coming in very early. So we started programming there also. So quite a lot of programming I did. But I think then I joined Infosys. So Infosys was a very transformation. It's very weird. I happened to work in the education research team where I was, because of my PhD, I was also teaching the new joinees in Infosys.
Yeah.
And as always, my mom is a teacher and my grandmother is a teacher. Everybody's a teacher. Teaching is the best way to learn. So you have, and we recruited only IITians then. So you had these people who cracked the best exam in the country and then thought they had done with their education. Why the hell am I sitting in training classes again? So they really had no interest. They just wanted to get into project and go abroad or whatever they want to do in 94, 93, 94 time. But teaching them was both challenge and it was sort of raises your bar in terms of ability to articulate, ability to explain concepts, the fundamental set theory based on which RDBMS was built, for example.
Yeah.
Unions, SQL, join is nothing but creating a set, intersections and so on. So that abstractions helped me. I think doing PhD also I feel, was very pivotal in getting abstract thinking very solidified. So you patterns and your ability to abstract that pattern and reapply came from my PhD onwards. Subsequently, of course, teaching also necessitated that. And because I was teaching, I also got a chance in as early as 93, I was working, early 94, I was already having internet connection. And I was programming very early CGI programming. If you remember that early days of using at that time pre-Mozilla, pre-Netscape days, the Mosaic browser, and the HTTP daemon that we used to download from CERN. So CERN's HTTP server and Mosaic was our tool pretty much. And a C program. You write C code and put it as a plugin to the HTTP daemon and you run it as a programmable web server at that time to create dynamic pages. So then Nandan caught hold of me and said, hey, you are already coding internet dynamics. So why don't we try? This was early 95 when we referenced internet banking experience. Building how consumer banking would dramatically change. So Nandan was one of those visionaries. You could see, that changing. And we did this and we showed it off to bankers, and bankers obviously we were way ahead of time. And they asked, what is a website? What is this internet? This was when branch-based banking, not even core banking, mostly branch-based banking, right, was going on. So I think Infosys picked it up later. So at 99, again, Pinnacle picked up the internet banking when it was okay for the society to accept it. But because I think the early days of my PhD and early days of teaching, I think was the fundamental shift in my not a normal programmer. I was forcefully elevated to abstract thinking, architectural thinking, concept explanation. If you can't explain why the hell is actually happening in the operating system level, why is the IO problem? Why is there a threading happening? I couldn't teach. And if I can't, then the IITians will just screw my happiness in front of me. They're all best students, So I had to myself to do that. I think that created a non-linear learning curve for me. To get to an architecture thinking, then in 96 went into the subsidiary of Infosys, Yantra Corporation, where we built a completely internet-based supply chain product, architected it. So, very rapid evolution to an architect straight away. I didn't spend much more time traditional coding, and I never became a manager. I don't even call myself a manager. I can't deal with project management and people management. I mentor people. I love people. I mentor people, but not the traditional project management constructs of a system integrator company, SI company. I just couldn't get around. So I was a product guy always, I think. So beginning and then I stayed with the product company until 2009. We had multiple rounds of venture raising, then subsequently got acquired. When I came back from you, started in Koramangala here in engineering. We had few of us who came back, who expanded our product engineering. It was all through my product experience. Very tiny company, 40 people engineers. We were actually 200 million valuation. So it was a very good company, got good acquisition. 2009, I quit all that thing and joined when the news came out that Dr. Manmohan Singh has invited Nandan to take it up. I had lost contact with him. So I contacted him and told him that midlife crisis or whatever you want to call, time has come for me to apply my large-scale engineering and architecture construct to do something societal good. Then onwards, everything else is public good creation.
Yeah, wonderful. Because that was one question that I had as to how you got into the scale thinking in the first place. Because what we notice is that when you talk about architecting a solution or building large scale solutions, you definitely need this abstraction. But then for implementing it, realizing it, you have to work on all the details. So how do you communicate with, let's say, an individual contributor in your team or somebody who's trying to realize your vision?
So I think one thing I always do is, because I come from a entrepreneurial product company background where we are barely running out of fund, we are raising fund, trying to compete with SAP's Oracle of the world. We were a small supply chain product company in the US. We are competing with the Siebel, all the big guys at that time. We had to be practical as well. So we are always marrying the product agility, ability to bring product out, capabilities out, while the foundation of the architecture is not diluted. So you want, because product companies, unlike projects, you don't get billed for building and you don't get billed for fixing bugs, right? You are a cost center. I mean, you in the product. So if you can do the same thing with half the people, that's even better. So per employee revenue is even better for a product company, right? So we got into the idea of first unbundling and isolation, that architectural constructor isolation. I always create small pieces and isolate them through a well-defined interface. And then I give the developer all the things, write dirtiest code you want. I don't care. Bring the feature up, but inside that isolation, nobody else should see it. The dirt you're writing, nobody else should see that dirt. So you might be writing let's say, a payment processing component, and you are not designing it for scale. You're not designing it for generalized architecture. So you might be hard coding stuff into it. Actually, I don't care. So actually, I really don't care. But I want the interface. First of all, is it a component atomic yet? If not, break it down. Break down the atomic pieces. It's like the class design with the interface, without the implementation. That I am very particular about. So I get my interfaces correct. Implementation can be dirty. So I tell people that quick and dirty implementation is because that's the reality of life. There is a release plan, there's a customer, there something has to go. Sales guys have already promised thing you can do. These are realities of life. So you have to get implementation. But what I bet on is two things. My interface is solid. My automation is solid. And I come from a world of interface automation, where again, throwing people at testing was not billable in a product company. Okay, so we couldn't go and tell customer, oh, we have 100 testers. Screw you, man. I don't care. So it's very important. So we had 100,000 test cases in our products, completely automated. So we had entirely API driven architecture. We can work entirely on API, and every API was automated. So we were so ahead of those two bets. API, which is the interface, how to design atomic interfaces, and how to automate it, so that you can write bad code and you can actually refactor without worrying. If you don't have the ability to refactor, so bring the ability to refactor through interfacing and automation. If you bring interfacing and automation, you can write dirty code. I don't care. I'll let you refactor, continuously refactor, where you bring scale, you bring security. You can't put the most advanced encryption initially. So you want to go with a quick customer table, user table. Just keep doing. But eventually you have to say, oh no, user email has to be encrypted. You can't keep the database like that these days. But no chance of asking these perfections that they want. So refactorability was an essential thing of a product, and especially with product company, where your product is not going away from you anytime soon. and all the bugs you create are yours only.
Yeah,
Like,
right.
right? So everything is an overhead. More bugs means more overhead. That's all is
Mhm.
going to happen. So we had a very good understanding of what it means to bet on interface design and automation. Only thing, if you don't know anything else from this talk, please take these two things out.
Okay.
Okay. Design atomic
Yeah.
break it down, design atomic interface, automate the hell out of it first before
Okay.
you even write any code.
Yeah. That does sound very easy, when you listen to it, but then I can already see a few other gray areas that probably need to be addressed along with this. For instance, when you say architecture, modeling, or you're trying to represent it, two aspects. One is you're trying to solve a business problem. So, which means that there is a certain amount of domain knowledge or domain related peculiarities, maybe the constraints, maybe it is the regulations, or maybe it is the way in which the industry works, etc. How can one quickly grasp that and then try to build it in the model? And second, just like you mentioned for the small services, saying that once you have your interface and the contracts all defined, then you can keep refactoring and evolving. Does that happen in your mind with the architecture also?
Yeah. So first point, let me answer the first question.
Okay.
I have always believed, and it's one of the maybe it's one of the reasons why I could succeed in the industry is also that I never was actually a techie.
Mm-hmm.
I was always a sales guy. I was always a business guy. I could always understand what the domain aspects were and was very keen to learn. And I would never say, somebody will give me a PRD product requirement and I'm only interested in some Kafka and database and all that thing. No, actually, I said, no, they are incidental. According to me, programming languages and tools were incidental. And people will keep creating newer ones. Okay.
Yeah.
What are you trying to solve?
Mm.
Whose care are you taking care of? So we have to understand the cares of the customer and understand the business scenario. So I was always in the middle of understanding what is really going on. But the art is in converting that ask. I can being in 20 plus years, 25 years in the product company, I have never seen requirements coming correctly. Never.
Mm-hmm.
Nobody tells you requirement correctly. Everybody tells you the elephant from their view. Little bit here, little bit there, little bit there. So our ability to not take the requirements of a customer as is important. So it means we have to apply our critical thinking and map what customer is trying to do and say, why are you doing it? And the why behind the why. And the why behind the why. I'll give you an example. One of the requirements in our product early days, we had a web search form for order. We were a supply chain management, so we were sales order. We could search sales orders and all that thing. And one of the requests came to me saying, we need the ability to copy paste copy from the internet page
Right.
because we had protected some field. So they said I can't copy it. It was actually very easy to make it copyable from that field, the text box copyable in HTML. But I didn't do it. I said, why are you trying to copy? Why were you doing what you're doing? No, I copy and paste it here. And we had a concept called linked orders because I had to find the linked order. So I used to copy this order number from here and copy it there and actually search it. I said, why? I'll give you the linked order link right there. I said, oh, of course, that solves.
Yeah.
So this is an important because by the time it came through tech support to our product management to as a PRD, the ask was this: make the text box copy pastable. And I am wondering, that's not a requirement. That doesn't make like it's not doesn't look like a customer is losing sleep over copy paste issue. So then I had to retrace and say ask. So I think asking the right question about functionality and what is the actual business problem is an important part of being an architect. And the second, never take it in the face value.
Okay.
Always ask more questions about what if this is a different product? What if it is slightly different domain? Because our product, because of our architectural, what we call generalization of the architectural construct, we started with e-com retailers, immediately went into logistics and DHL, FedEx, everybody used worldwide, fourth party logistics. We could go into adjacencies very easy using the same product because we didn't take the requirement hard coded into the architecture. So putting the business ask to a generalization of the architecture is very key. The generalization comes from visualization. So that
Right.
goes back to your last question. Do you visualize this? Absolutely. In fact, I can't think anything other than pictures. Okay. I actually, if I
Okay.
can't get a simple picture in my mind, if I can't explain, again, my teaching may be helping me. I always ask the question, can I explain this in a very simple term to somebody at all? This architecture.
Mhm.
If I can't explain this, I have complicated it. That's my argument. That beauty of that architecture comes from simplicity,
Mm.
of that thing. So we have
Yeah.
to be able to constantly refine it. That means you have to close your eyes, imagine it, and saying that happening. So that require business understanding, converted to generalization of the architecture, converted to generalized interfaces, getting it right, even if you don't get implementations, just getting interfaces right is a very important aspect of it. And also being a product company, we learned very quickly about the generalization and externalization technique. What it means is that I generalize the architecture and make the fungibility available as configurations. So
Okay.
that means product can be reconfigured and rewired like building blocks, like a Lego block. That because as a product company, if I didn't do it, it was not a project. We were not doing exactly what customer asked. We were a product company. We were selling it to every retailer in the US, every in the UK, and logistics companies. So we had the same product, only one product we had. So
Mhm.
it was
Yeah.
I think the product experience is very different, I think, from project experience. I see the difference between engineers
Mm.
who worked on products thinking differently. They think long term, they think configurability, they think evolvability, product guys. Whereas project people who have been in project mode, I don't see them thinking that way, because a customer asked me, my on-site guy wrote to me this document and said, just coded it.
What is it? Yeah.
Yeah.
Okay. Good. Uh, yeah, that brings me to another concept of probably systems are now evolving that way from, let's say, bespoke applications to saying that I'm creating a product, and then people talk about platforms which are a little more flexible. But nowadays, when you see all the solutions are more like ecosystems, in the sense you don't build everything. So you need to work with others, you need to have interoperability. So there are two questions there again. One is, how can you foresee changes and what do you build in the architecture for that resilience? And second, while you mentioned something like encryption and things can be bolted on later, probably some security is something that you cannot. You probably have to think it through, and that too with increasing supply chain vulnerabilities. Now, wherever it is, particularly if you are mixing and matching components from different sources, can one handle that as an architect?
So I use this word when I say encryption, ignore it. I didn't mean I ignore encryption. Never design security and privacy and overall design, evolvability as a design, generalization of the objects you are designing. Design it correctly. You don't have to implement it on day one. I think that subtlety is what is making you not freeze in time. Otherwise, you're always under this pressure of something you have to implement. You have to get something out in the next month and then something in the next month. But at the same time, you're talking long term. So how do you marry the long term? So I always tell my developers, design for a decade,
Okay.
implement for today.
Okay.
That is very key. And that balancing of designing, so that means you design the interfaces, you design security, you design privacy, but you can implement some parts of it basically on a tactical aspects of it. Okay, not this month. Okay, let me put it in the sprint next month or sprint next after that. And is there a customer really going live? A lot of times when you do a product, they're not even going live for the next 6 months. So you have a leeway in fixing some of these as you go instead of freezing in time. So I'm talking about implement. Design has to be for a decade. And I think it's very important to get it right. But I think you asked the question, how do you make it evolve? For example, when we did the API, Aadhaar authentication API, we wrote in 2010 or 11 actually, 2011, I think I published it. Hardly went through change. It was so forward looking. It had PIN, OTP, TOTP, we had phase in there, but we never implemented phase. We are barely implementing now, by the way. Phase as an authentication, because we had no smartphone just came in 2009. Android came in 2009. We were designing the interface for forward, and that then we would have a error code, so not yet implemented error code. So we have that API is there, but not yet implemented. But it was, this interface didn't have to go through much change at all. And then we always find a way to make backward compatible upgrades to the interface.
Okay.
Knowing that an ecosystem, I think you brought, everything is an ecosystem. Everything, there is no existence of you as by yourself. You are a product company, you exist because of everybody else around you. If you are a supply chain company, if you are a Flipkart or anybody else, you are on one side, supply side network and the demand side network. You're always in between some network, right? Given that your architecture, this is why the API based architecture, which for some reason we had implemented as early as 99. We only wrote APIs at that time. It was very interesting that we were ahead of time. But today, I think most of the people do it, knowing that you are in the ecosystem. I think that API is the interface that you design it for forward-looking design. That means you think about, could card change, like UPI. I don't know whether you actually have read my original UPI paper where I describe the idea of virtual payment address and how the VPS, you get today, Shiv at UPI, YBL, you have these codes, right?
Yeah.
How I had designed it. Today, I can convert a credit card, debit card, or any payment instrument into a virtual payment address. That is why when FASTag came, ETC came, your car registration number became a VPA, right? You can actually recharge your your FASTag in your car by sending money to K51MA01. Yeah, literally, your car number. There is no bank account in that name. It is a addressable payment address, right? A receptacle of a payment. How can any receptacle of a payment be addressed in a URN format? Normalized format. Was what I wrote in 2014. So that was very because that is what you think about it. You think about how can newer ways of doing things can get nicely into the same design. How do you generalize it? But we implemented none of that at that time. Implemented only minor part of the spec. So it's very important that implementation is where you get leeway. Design, you don't get leeway. If you don't get the design, your house foundation itself is weak. That you can't patch foundation. It'll crumble. That's what will happen.
Okay. Yeah. So that throws up another question. Nowadays, everybody wants to be agile.
Yeah, of course.
Okay. And one of the things is then don't spend a lot of time on big upfront design. Okay. Make failures. It is okay. Keep releasing. Keep evolving. So, what is your perspective on that?
Yeah, of course. If your design takes months, then you have a problem because nobody has patience to wait for it. Frankly speaking, not all design. Some design might take long, but not all design do take that long. But I am still of the opinion that if you design correct, your coding time is dramatically slashed. If you design correctly, if you've automated fully, then your fixing time and enhancement time and refactoring time is dramatically reduced because you can confidently refactor knowing that your regression suite will catch it. Otherwise, you are expecting some human being to test it. You are scared of touching your own code. That's what happens after some time. It's all a write-only code, only once, right?
Yeah.
Then you start putting big if statements. If this, then else, and all will happen. Because you can't, I don't know what is going on in that code. Because I think testability is what is causing this fear. So I would actually argue that taking upfront design time can't be months, but design time is essential, absolutely essential. It's a wrong thing today to say, start coding and we design it later. That's stupid. I know national scale system can happen, I can tell you. If you are dreaming of a national scale system, or if you are dreaming of becoming Paytm, or if you are dreaming of becoming Flipkart or PhonePe, you can't be the foundations of the design and also the DNA of the engineering matter more to me at that time. Because the DNA of engineering is to get good design thinking right, good interface and automation as an DNA, then we can literally let people unbundle, isolate, interface, automate.
Okay.
Then you write whatever you want. Also, there's young engineers whatever they taught you in college is probably all wrong. They taught you how to code, how to do indentation, and it's probably even scored you for indentation. It's a sad thing. Or curly parenthesis missing, the teacher cut a half mark and all. Totally useless. Now you think about interfaces, think about design, think about what interface also takes the ecosystem play, because interface is not only outside ecosystem, even inside your own organization you have other systems. So interoperable, you are not never alone. So and whereas manufacturing world has done this really well. Imagine the car guy, Toyota guy is not building all pieces of the puzzle by himself. Toyota is procuring that large scale, anything that is happening at human scale, manufacturing, building houses. You think you're building houses, the guy who built bricks and windows and everything is interoperable. You can actually build. So anything human scale is always interoperable. That means they all assume that we can't be solving everything. We are only one part of it, and we should fit in nicely. To fit in nicely, you need to have interfaces well designed. Software is becoming that way these days, thankfully. It's no more an enterprise monolithic world. So I think engineers have grown to appreciate this ecosystem and API thinking much more. So hopefully they're getting the isolation and interfacing and automation right.
Yeah. Okay, again, probably nostalgia. One of the classic books, Mythical Man Month, and those days, there was this concept of a chief programmer team. I mean, they didn't call it an architect or a tech lead and all that. Versus designed by democracy or designed by consensus. So for large systems or even probably smaller systems, even within an enterprise, should there be one architect who conceives everything and then realizes it with a team, or can it be done by a committee?
Can never be done by a committee. I can tell you that for sure. The committee is a bad word, but doing by committee. But I think the way, at least I have seen it happening in my experience. I can only share what worked for me. Absolutely. I don't know what is reality. Is that we always had a benevolent dictator sort of role, who brought consensus among younger architects. So there are, let's say, we have 5 modules, and there are 5 modules who are working on it. There are some young architects, but there is always someone who is making sure the coherency and the long-term views brought in, and the experience of being in that system, being architecting, customers screaming at you, something blowing up when you did a patch release, some other customers complaining now in product. All these experience are brought by senior people. So it's not a bad idea. At least for me, it worked very well that one benevolent dictator there mentoring, guiding, but occasionally making, if there's a conflict, resolving, saying, no, let's do it this way. It's not a voting business. I heard both sides. I heard all of you, and here is my directional thing to do. I think it's required. Otherwise, you don't get the coherency coming in. But if there are completely independent modules which have nothing to do with it, each of them can have their own team. I mean, it's not that one pyramid structure has to be created. I'm not saying that at all. At least if there is a unified, integrated product, one chief architect would help. But that has to be not a one other thing. Again, I think this is very important. The chief architect should not be in the line of management. What it means is that I should not, if I am the chief architect, I should not have people reporting to me. Actually, I never had people reporting to me, by the way, in my 25 plus years. But I had a lot of people I mentor, I have a lot of people I drive architecture with. So having an engineering management different from the architecture is good, because then you can only mentor. You can't bulldoze. You saying that I'll screw you on your performance review next year and all. It can't happen, no. Because you have to convince through intellect. You have to because that guy doesn't have to listen to you. That is a good setup. Not a full democracy, but it is a mentored, guided democracy. I think that would work well. Not a pyramid management structure, for sure.
Okay, good. So far, you shared a lot of good practices that people can use. So from your experience, do you have any horror stories of design decisions or architectural decisions that went wrong, or that were invalidated when you actually went out to the field? Or...
I think I would think many experience actually that way.
At least maybe 1 or 2. Okay.
So I'm
We try to keep the conversation a little light. So some of these things, tell people, oh, I also did that.
Yeah, no, I think I'll tell you one of the early architecture learning I had. This is in 2002. 2002, when we had Hallmark as our customer in the US for the product we were selling. And Hallmark has the biggest volumes coming in post Thanksgiving, around Thanksgiving time, through Mother's Day and Valentine's. That's sort of where especially we were on the flower side of the Hallmark. Hallmark in the US had flowers and cards. So the flower side.
Yeah.
So one of the things they had was they had a very interesting scenario where because we were API based engine, we had incoming integration and outgoing integration.
Okay.
And we had our incoming integration from their website, the flower ordering website, into our order management, and then outgoing integration to their warehouses to actually ship it. And also to their infrastructure, like sending SMS. So at that time it was email, so we were sending emails. So we had an SMTP server configured in their production. It was not a SaaS offering. It was a 2002, so enterprise product. Then one of the design decisions we had is the flexibility. So I wanted a lot of flexibility because we were early into the product. But flexibility backfired on us. That is the experience we had when we had no what we call debuggability, manageability, or debuggability at scale. What it means is that we have a production running, and production is not in our control. We are a small product company, 40 people sitting in Boston, developing product. These guys are somewhere running their own data center, their own website. One day call comes. Or your order management, order taking API, order confirmation API is extremely slow. It is slowing down like crazy. Imagine what would a small engineering team sitting here? We have no access to the production center. It's not a SaaS where today that is one of the messy things people do. People go straight into production, do SSH, try to do log files. We were not allowed to do because we had no legal access to their environment. Forced. And one of the things, we couldn't do anything. We just didn't know where it was. What do you mean by slow? What is actionable when somebody says something is slow?
Slow.
I don't know.
Yeah.
And we had to send our chief scientist, one of the performance scientists, a wonderful guy, Chinese guy, was brilliant in there, sent physically to Hallmark, that company's headquarters, go sit there with them. And of course, CEO immediately called and said, we are not going to charge you because your problem is our problem. We will make sure this is not a service cost or anything. We are sending you the best performance guy. He'll come. When we debug, what was the issue? It was extremely simple. The call was coming from website to us. We were making a call, and we were making a synchronous call to an outbound interface. That system, somebody had brought it down for management or night. So every evening they used to have that guy didn't know. So the one thing I realized that two things you have to build in any interface design. External, especially outbound ones. Always make it async. Okay, that means you are not holding up your thread. Otherwise, it was like Silkboard. Everything was being piled up, and all the threads were busy, and we were crashing. We didn't have any other, nothing to do with us. It was simply because that SMTP system was actually being maintained. So every window they will do some restart, and suddenly ripple effect all the way to the website. Okay, so asynchronous design, asynchronous interface design was a fundamental. That's one I learned about very quickly. We had to do async. Second, how can we not send human beings to customer side? Because what will happen if more and more issues start coming? Small product company, we'll be in plain. We would not have anybody coding. So I built something called a traceability architecture into the system. It's not a Java traceability. We didn't do Java-based traceability because production we can't do. We built an extremely lightweight in-memory trace. At the thread level, we can turn it on. And we could turn on and it would generate small independent trace files just enough, zip it up, and with the customer consent, send it to us in our tech support. When everything is going on, when customer website is most peaked at afternoon or before Mother's Day, you can't say put a debugger in the system. So how do you do a lightweight tracing, lightweight debugging? In-flight debugging was another second learning. These two patterns I had never realized before 2002. Design patterns. So we had to do it in 2002. Now, of course, I tell everybody, don't assume the other side is working. You have to make sure. And especially with the ecosystem and networked architecture, you are only one piece of the puzzle. And you don't know due to what effect your being slowed down. So how do you bring resilience and debuggability at scale was an important.
Okay. Yeah, very nice. So normally I have one favorite question that I ask all our guests as the last question usually, saying that your career advice. Now, in your case, I think you've already given a lot of tips and a lot of areas that one needs to probably specialize in or even thinking, etc. Is there a quick test for someone who's either considering becoming an architect or somebody who started as an architect? Am I a good architect? How do I find out? Or can I be a good architect? Is there anything that you would say, at least quick aptitude?
I think the three, I was telling you, right? The three things, actually four things. I'll talk about four things. One of them is actually deep knowledge of the computer science, inevitability. That is obvious one. If you don't really understand how operating system processes work, how threading work, why the index tree in a data structure, large scale, when it becomes 100 million or insert intensive, why is it going skewed? It's not a balanced tree anymore. I mean, the fundamentals have to be there, okay? You can't avoid it too much. So learn that part very well. You can't somehow show up as architect. That's fine. That's okay. That's the obvious one. The other three are actually non-technical. One, tremendous understanding and inquisitiveness about the business and the actual problem you're trying to solve. Okay. Huge. If you have not been a question asking guy, if you're not the guy who's been asking questions with customers, wanting to, how does the hotel industry, oh, you're in the hotel industry, oh, you're working Swiggy, how does it work? How does it work? How does menu get represented? What's going on? If you're not one of those guys asking business question of what is really going on, what is the problem, where are you seeing issues, you are not going to be a good architect. Second, the second part of it, if you are not able to do this abstract and reapply, it's somehow maybe you can test it through trying to redesign. Let's say you don't understand UPI at all. Maybe you can try, if you were UPI architect, what would you have tried? And then do a comparison, saying that what did I get it and what did they do? Is not to do a plus and minus, just to see if you are also getting the idea of abstractions correct. Okay. The second part is abstraction. And the third part is the visual and communication element. If you are not been standing up and presenting in sales calls, if you are one of those guys who are getting called in sales to explain concepts, you are probably a natural architect. Okay, that means you can't be an architect without having the ability to visualize it and articulate. The ability to articulate in simplicity, simple terms, explain to people and why you're doing what you're doing. You can't just say, I know computer science, this is my way, I'm just going to do it. I don't know how to explain all this shit because customer doesn't understand tech. Okay. Yeah, customers never understand tech. They shouldn't understand tech. So I think the idea is that, so these three characteristics are very key. Deep appreciation of business care and lots of inquisitiveness. Second, abstracting power to reapply patterns. If you are seeing patterns, you should be able to correlate patterns. Okay. Third is ability to visualize and communicate. If you are one of those guys who have been getting good kudos about your presentation skills, ability to talk, maybe you're good. Yeah. Other than computer science being foundations. Okay. That is the fourth one. Okay.
Thanks a lot, Pramod. I think that's about all the time we have for now. But I'm sure there are enough topics that can spawn off more such conversations. Hopefully, we'll catch up in the future.
Thank you so much.
Thanks.
We thank Siddharth for the music and Malavika for promoting the Software People Stories.
If you like this episode,
please subscribe on your favorite podcast client
and spread the word in your network.
If you'd like to share your story,
contact us at podcasts@pm-powerconsulting.com.
This podcast was created on Hubhopper Studio. If you wish to start your own podcast for free, visit www.hubhopperstudio.com. Hubhopper is India's leading podcast creation platform. Start your podcast with Hubhopper Studio and you get your voice heard across platforms like Spotify, Gaana, Google Podcasts, Wink Music, and more. Click on the link in the episode description or visit www.hubhopperstudio.com.